Welcome to The Explainer. So today we're diving into this huge split, this great divergence that's happening in AI right now. It's a wild story, really. It's about a wrong turn that might have sent the entire industry off course, a swamp of stagnation, and two totally different roads being carved out for the future.
Okay, so let's get right into it, because this is the big question, right? How can AI feel both completely unstoppable and kind of stuck at the same time? I mean, you see the headlines, trillion-dollar companies, promises of godlike AGI, but then you actually use the products and they feel, well, a bit brittle. They're expensive. And are they really changing the world the way we were told they would? We're going to get to the bottom of that.
All right, here's how we're going to break it all down. First, we'll talk about the Great AI Detour. Then, what caused it, this clash between physics and profit. We'll see where that left us, stuck in the meadow. And from there, we'll look at the two paths forward and, of course, what might come next.
So let's kick things off with this idea of the Great AI Detour. You know, we tend to think of progress as this straight upward line, but that's just not what happened here. The story of AI, at least according to the sources we're looking at today, is a journey that took a really specific and, as it turns out, a massively consequential wrong turn.
And that wrong turn has a name, the hard left. Think about it like this. The industry stumbled upon one incredible discovery, these scaling laws. The idea that if you just throw more data and more computer power at a model, it gets better. And instead of saying, wow, that's a great clue, let's find more, the industry said, that's it. That's the secret sauce. And they went all in, just industrializing that one single idea. They basically stopped searching for better ideas. And that decision steered the whole field away from the goal of true AGI and, well, into something very, very different.
Okay, so you got to ask, why? Why would an entire industry full of brilliant people take this hard left? The answer, it turns out, isn't really about the tech. It's something deeper. It's a philosophical clash, a battle between two completely opposite ways of looking at the world.
And this slide just lays it out perfectly. On one side, you have physics. The whole point of physics is to find the truth, right? To figure out the fundamental, unchangeable laws of how things actually work. But on the other side, you've got capitalism. And capitalism isn't about truth. It's about optimization. It's about finding an advantage, maximizing profit, winning the market. It doesn't really care how something works, just that it does work well enough to make money. And that hard left, well, that's what happens when the drive to optimize totally bulldozes the search for truth.
And then you get this quote, "We're physicists who are also capitalists." I mean, wow, that just says it all, doesn't it? It's this perfect snapshot of the cognitive dissonance, this attempt to be two completely opposite things at once. But let's be real, you can't serve two masters forever. And when billions of dollars are on the line, which one do you think is going to win out? Yep, optimization.
So this decision was made, optimization over truth. The hard left was taken. So where did it lead? Where are we now? Well, we're definitely not in the promised land of AGI. Instead, the industry finds itself stuck in a place the sources call the mossy meadow. And this moory meadow is just a perfect metaphor, isn't it? Picture this swampy field. It looks kind of green and lush from a distance, but when you step into it, you realize the ground is just saturated. Not with water, but with billions and billions of dollars in investment capital. And it's almost impossible to move forward. This is where the industry is now, producing these super expensive, incredibly inefficient AIs that look amazing on the surface, but are hitting very real, very hard physical and financial walls.
The key thing to understand about the models being built in this meadow is that they are incomplete simulations. And this is where it gets really important for you, for all of us. These things are phenomenal mimics. They can copy the patterns of human language and reasoning so well it's scary. But they don't actually understand the underlying reality, the physics of what they're talking about. And that's why you see all these problems. It's why they feel so brittle, why they get stuck in these weird bug loops, and why they have this massive generalization gap.
And if you want a perfect example of that generalization gap, look no further than this number, 20 hours. That's about how long it takes a teenager to learn how to drive a car. Why? Because you're not just memorizing pictures, you're learning the physics of it all, inertia, grip, what other drivers are thinking. Now, compare that to a self-driving AI. It needs to see billions of video frames just to simulate driving. It's not learning the way we are. It's not getting the truth. It's just getting better and better at faking it.
And this inefficiency, it's not just a software problem, it's a physics problem. It's a thermodynamic reality. Just look at this table. The standard models we have today, they run on really complex, energy-guzzling math.
Think of it like doing floating point multiplication over and over on super expensive GPUs. But now you're seeing these new ideas pop up, like one-bit LLMs, and they're trying to get by with way simpler math, more like just doing basic addition. This whole shift, it's basically a desperate cry for help. It's an admission that the current path is smashing right into a hard energy wall.
Just look at that number, 71.4 times. That's the potential energy savings here. Let that sink in. That's not a small tweak. That's not a 10% improvement. That is a complete game changer. And it shows you just how intense the pressure is right now to find any way to escape the insane energy cost of being stuck in that meadow.
So you've got this stagnation. You've got this energy wall. What happens next? Well, a split, a huge one. The AI world, which for a few years seemed like it was marching in lockstep, is not doing that anymore. It is now splitting apart, diverging onto two totally different paths, both desperate to find a way out of the meadow.
And this table really puts it into perspective. You had the age of research, right? This was driven by brilliant new ideas, often tested on just a few GPUs. It was about ingenuity. And then we entered the age of scaling, which is where we are now. It's not about ingenuity anymore. It's about capital and energy. It's about who can build the biggest cluster of 100,000 GPUs. So the billion-dollar question for everyone in this space is, what's the next age going to be?
So path A. This is the market's path. The logic here is simple. If what you're doing isn't working, just do it bigger, double down. This whole thing is being propped up by what the sources are calling the NVIDIA distortion field, which is this wild situation where NVIDIA is basically bankrolling its own biggest customers, creating this circular loop of money that just keeps inflating valuations. And on top of that, you've got governments jumping in talking about sovereign clouds because they see massive AI clusters as a national security issue. So the strategy for Path A is dead simple. Build bigger computers, period.
But then you have Path B. And this is a complete 180. It's a radical pivot back to science, led by people like Ilyas Etskever. The core belief here is that scaling is a dead end. The way out of the meadow isn't a bigger truck, it's to go back to the start and find a totally new map. So the strategy is to get away from the pressure of quarterly earnings and shipping products and just get back to basic research to try and find the actual fundamental principles of intelligence.
So you've got these two paths splitting away from each other. And the market, which is all in on Path A, on the scaling path, well, it's getting nervous. It knows it's up against the laws of physics. So it's desperately looking for a get-out-of-jail-free card, a wild card, a deus ex machina that can somehow save the whole scaling paradigm.
And what's that wild card? Quantum AI. This is the big hope, the potential silver bullet. The thinking is that maybe, just maybe, quantum computing could come along and completely shatter that energy wall. If it could somehow make today's incredibly inefficient models cheap to run again, well, that would be a massive shot in the arm for the scaling machine. It would let them kick the can down the road and put off having to find a genuinely better idea.
And so all of this leaves us right here with this one ultimate question. What will AI's future belong to? The biggest computer or the best idea? Is the answer more brute force? Or is it a quiet, difficult return to fundamental science? The path that wins this fight, it's not just going to define a multi-trillion-dollar industry. It's going to shape the technology that fundamentally changes all of our lives for the next decade, and maybe beyond.